Hello everybody, welcome to Gregg's Vintage Workshop, where I'm working to restore history one piece at a time. Today we're going to be starting part 1 of the 1929 Victor R-32 TRF radio. This was built the year of the big stock market crash, and this was also before RCA and Victor joined together, so it was just Victor. So we did an intro the other day on it. Tonight we're just going to delve right in there. I've gotten some materials, schematics, diagrams, drawings of the radio. Bob from over at Robert Gibbons, he was nice enough to get those for me and send them my way. So thank you, Bob. We're just going to start tonight on the power and amplifier unit and take a look at that and see what we find. Without further ado, let's get started on that. Okay, to kind of give you guys a lay of the land, I've got it flipped upside down. So, to give you a little bit more orientation before I get you in the tripod, this line of 5 terminals here is the filter condenser can, that great big can. This is a tab, this is a tab, this is a tab, this is a tab that holds that in place. We have a big power resistor here. This is the big plug that the amplifier and the speaker plug into. Okay. This is the power in. This would be the phono jack. This is a tone control. This is a hum control. These are the various tubes going down here. This is a filter condenser can here. I believe this is a filter condenser here. I'm not 100% sure. I haven't checked it yet, but to give you a lay for it. This is the power transformer. This one, I believe, is the filter choke. This one is the input transformer, I believe. And then this one would be the output transformer and the interstage transformer here and here, if you guys can see that. I'm going to have you zoomed up to that. Hopefully you guys can see this. I turned one of my lights off so that we could get a better view of my ohm meter. So, considering the big bad transformers, the power transformer with so many windings on it, that's the one I want to look at first, because obviously if that's bad, that's bad. That's a bad, very bad thing. To replace that would be literally impossible unless I could find another one of these R32s, which they are around. From what I've been told, there's made like 179,000 of them, but it's not like you come across them every day either, so I don't know how well you guys are going to see this, so you just have to take my word for it here. So looking at this particular schematic right here, I have the power transformer right here, and I've labeled all of the various windings, like 6 and 3 is the primary. There's some filament windings and stuff on here. So I've got those written down. So we're going to be looking at the power transformer. This is the output transformer. Here's the interstage transformer and the input transformer. So we're going to start with the power transformer, and we will do the primary first, which is terminal 3 and terminal 6. And as I showed you guys before, I have pre-labeled these. Unfortunately, my camera's in my way, but I'm hoping I can make it. This looks like 3, and let's see, 4, 5, 6. This should be 6. Well, there we go. Okay, 3 ohms. So that primary should be good. Alright, now let's go between terminals 2 and 4, which should be the coil that's feeding the 27 tube filament. So 2 and 4, see, this looks like 2, and 4, it's this one right here, 0.3 ohm. For a filament, that should 0.2, 0.3, that should be about right for a filament. Next we'll look at 5 and 7. That's the filament for the 26 tube. So 5 and 7. Let's see, here's 5. And let's see, 5, 6, 7 should be this one right here. We got 0.3 for that one, 0.2, 0.3, so that filament's good. So now we're going to do terminals 10 and 11. This should be 10 and this should be 11. 10 and 11 should be the 80 tube plate. 10, I'm on 11. 309.2 ohms. Okay. Now that one has a center tap on it, which is 13. So let's see, 13, 14, I think this is 13 here. We're about 209. And then, so then 13, and I'm on 10, so we'd go 13 to 11 should be the other portion. And we got 100, so those add up. 100 and 209 is 309, and that's what we had, so that's good. Alright, so now let's go to 14 and 9, which, let's see, 9 should be this one, and 14 should be this one. 14 and 9 is the filament for the 80 tube. Oop, fell off of it. There we go. 0.3. Now we're going to look at 17 and 12, which are the 45's heater filament. So let's see, 12. Even though I get these numbers, it's still not that easy because my camera boom's in my way. So here's 12 and 17. 0.3. That's good. And then for the 26 tube on the power amp, 13, 14, 15, and 16. And we've got 300 ohms. Okay. So I think I've got them all. So that appears to have tested good. I didn't have any open windings at all. Now, I guess I should check them all to ground. Now, everything's still in the circuit, so I don't know how well this will test to ground, but so here's one. We got 2 point, see, that's connected to a cap obviously because it's increasing, but it's mega ohms. There's 2. Oh, if I can get it as 2. There's 2, open. There's 3, that one's increasing, that's a cap apparently. 4, open. 5, open. 6 mega ohms and increasing. 7, open. 8, 700K, 700 ohms. 8 is a center tap, so that doesn't surprise me any. 9's open. 10 mega ohms. 11. 13 is a center tap. 14 mega ohms. 15, 209 ohms. I'll have to look at that one a little bit closer. 16 open and 17 is about 700. Okay. I'm confident that that power transformer is likely good. Like I said, the wiring, and there's some resistors and caps feeding in that's nothing's disconnected. And I really don't want to take anything loose that I don't have to take loose, because this old wire is so difficult to solder. I'd rather not take loose anything I don't have to. Now I do notice right now there's a rubber wire right here that's all cracked. So I'll have to do something with that, obviously. It looks like a separate wire. It is. It's actually a separate wire. One over here too. So the separate wire, it looks like the separate wires were made out of rubber and they're cracked. The other ones are fiber wires. Okay. So now let's move on to the output transformers right there. So I guess we should go with it. Primary of the output is terminals 1 and 2. So 1 and 2. We got 2.7 ohms. And let's see, 4 and 5 would be the secondary. And we got 533, about 534 ohms. And then the center tap is 3. So we go center to 5, about 266. Center to 4 is about 266. So that's good. Output's good. Alright, let's move this meter over, hopefully where you can still sit. Angle it. And we're going to move over to the Interstage Transformer. Like the primary on that one is 1 and 2 as well. And we've got 2354. So 2350. And then we'll go to 4 to 5. 4 to 5. Looks like we got 523K. Okay. So now let's go to 3. We're at 8.3K, certainly not half. And 3 to 4 is 516K. And I'm back on 4 to 5, 523K. 3 to 4, 515K, and 3 to 5, 8.3K. That doesn't sound good at all. That doesn't sound right. Not based on this schematic. There's a tap. See, I don't know if you guys can see this or not. It's so small. Where is my magnifying glass? I don't know if you guys can see this through the magnifying glass or not. Let's see if that makes it any better. Probably not. But there's definitely a center tap to ground. And I've never seen a center tap that was that far out of whack. That there'd be like 8,000. Let's just recheck that again. Let me look at that again. So 4 to 5. We're talking 420. Just climbing a little bit. Let's let it neutralize. Let's say 525. So let's say 525. Let me write that down. And now let's go 3 to 5. We've got 8,300. So it's 8,300. So now let's go 3 to 4. Stopping at about 516.6. I guess if you added those two together, the 8,300 to that, it adds up. Huh. I've never seen one that's tapped to be that far off. I mean, I don't know. Maybe somebody's out there, one of my viewers smarter than me, can tell me if they think that that is good or bad. I mean, it apparently is adding up. When you look at the schematic, it looks like it's in kind of the center. It's certainly not moved over enough that would make you think that one side would be that much different than the other, but maybe it's okay. I don't know. Alright, let's move over to the input transformer. This one's laid out slightly different. I'm going to recycle my meter just so it don't go off on us. 3 and 5 must be the primary. So here's 5. Here's 3. So we got 11K, 11.15K, and then 2 and 4 are another one of the what you would consider the secondary, I'm assuming. 2 and 4. So here's 2 right here. And here's 4. It's open. It looks like it's open. Okay, so let's look at the other one. Looks like 1 to 3. So 1 to 3. We've got 36.8 ohms. Okay, so I'm not sure. I don't think that that's good. I don't think that well, I know 2 to 4 is open for sure, so there's no doubt about that. 2 to 4 was open. Test that again. 2 to 4. Yeah, 2 to 4 is open. Well, that ain't good, folks. It means my input transformer is bad. My interstage transformer may be bad. That one may not be bad. The interstage may not be bad simply because it didn't test open. You know, I had the 2300 ohms between 1 and 2. I had 528 or so, 529 between 4 and 5. And then I had about 519K between 3 and 4. 3 being the tap. Keep calling it a center tap. Maybe it's not a center tap, it's just a tap. Because then between 3 and 5 I had 8300. So if I add the 8300 to the 519K, that pretty much comes to the 528. So I'm thinking now that the interstage transformer may be okay. See, the problem with this old R32 and all of the diagrams and stuff, the information with it, it doesn't give you ohm readings for the coils for the transformers, so I can't compare it to nothing. All I can do is, if I get it working, I can look at the voltages and see what things are doing. So right now I may realize these things are all embedded in tar, and knowing that my output transformer is good and it shares the same CAN as the interstage, I'm thinking that I'm gonna leave it alone and assume it's okay. And then all I have to worry about is the input transformer, and on the input transformer I got an open. So I need to come up with an input transformer, but I have no idea what input transformer I would use. I don't know, maybe some of you people out there that are smarter than I can let me know what input transformer you think would work with this. If you get out an R32 schematic and look at it, obviously the input transformer has to work in the circuit. Anyway, okay, so that's where we're at. That's very bad news. I was actually hoping that I was not going to have any bad transformers. That's kind of what kills projects like this. I'm not deterred though. I'm not gonna say that this can't be fixed, because I'm sure that I can substitute an input transformer for what's in here. Now we could go ahead and check these caps, but I think I would have to lift the wires off in order to get any type of a good reading out of them. Let's just see what happens. So if we go to terminal 1, it's supposed to be 2 microfarads, and it's not really reading anything. So let's go to number 2, which is supposed to be a 4. And don't like it. Go to 3, which is supposed to be a 6. It's actually measuring about 7.6, so at least I got a reading on that one. And then let's go to terminal 4, which is going to be, should be a 4. And it's reading 7.6. Now, I'm not going to trust those caps at all. Just like if you've watched my Atwater Kent 1929 Atwater Kent 55C video, you saw me open that can up and get those big old humongous caps out of it. I'm going to do the same thing on this one. I think I'll go ahead and stop this here because I've got to do some research now to determine what I can do with this input transformer. This is caps in here as well. I'm not sure the value because I haven't really looked at this one that much. So I don't know how well this is going to show up. Probably not. This would be the cap right there. Bypass condenser. Let's see. Bypass condenser. 0.135 microfarads is what it looks like it's saying. Yeah. Bypass condenser pack comprising 3 condensers, a 0.1, a 0.1, and a 0.125 microfarad for the 60 cycle. So that's what we've got. And that's where I could see that one that was a 0.125. So yeah, so we'll redo this. I want to keep everything looking, you know, as original as possible. I realize it's not going to be seen. I just feel better in my own brain about that when I do that, kind of like I did the Atwater Kent. Now, obviously, you flip the Atwater Kent over, you can see modern resistors. And this one, if by chance these resistors here are bad, these 3 resistors, which I think are grid bypass, I think they're supposed to be like 0.5 meg, but I don't think that they're going to test unless I get them out of circuit. Let's just see what they do, but I don't think they will. Let's test one here anyway. No, see, that's only 8,300. So they're going to have to be taken out of circuit to be able to test them. Now, because these 2 are 45s here, that one's half. That one's measuring about 0.5 meg. At 516K. This one and this one are both the 45s, and they need to be matched as close as possible. I'll have to lift this one off to see what it actually tests at. You know what? I'm going to do that right now. I'm just going to snip the wire because I got plenty of lead right here. So let's just snip this wire part of this off and just test it, because out of circuit it might be closer. Because if it's way off, I'm going to change them anyway. Yeah, it's 453, which for this type of resistor, it's lower than the spec, but again, they probably had much different tolerances back then. So this is 453.5. This other one was measuring almost 100,000 higher. About, not 100,000, about 60. But I'd feel better about having, for the 245s being matched. this other one down here. You guys can't see what I'm doing probably. I didn't realize I was almost off screen. Can you see that one? Yeah, you can see that one. Let's see what this one right here, this last one's doing. Yeah, that one have to come out of circuit too to be able to test it. But if I do replace these, I may try and make some that look like this. I don't know. I have to think about it. I'd like to keep it looking as original looking as possible. I've never made a dog bone resistor. These aren't round. These are more like octagonal shape. So I don't know. I don't know. I might. I don't know. Right now, that's at least my worries. I got to figure out what's going on with the input transformer, and somebody else that's smarter than me can let me know about that interstage transformer. But at this point, I'm considering it going to be, I'm going to reuse it because I really don't want to take the output with it testing good out of that tar. I mean, I could probably somehow split the tar, so I only brought the one out, but I really don't want to do that. At this point, I think I'm going to try and run it because it may be okay. I may only need to get the input transformer. So I think I'm going to go ahead and wrap this up because I want to get this video out to you guys so that somebody smarter than me can let me know about that input transformer. I'd really appreciate it. Obviously, I need to do some cleaning in here. I have to change some, obviously replace some components. We'll go through the cap. The next video, I think what I'm probably going to be doing on the next video is we'll take the big cap condenser can out and we'll detar it, and I'll put new caps in that. I'll probably do this can, maybe not in the same exact video, but we'll be doing it. So I'm going to go ahead and end it here. This R32 is going to be a fun project. I just hope that I can get the part that I need for it. Let's go ahead and end this one. So if you're not a current subscriber, I ask that you'd subscribe to my channel if you've liked what you've seen. Even if you didn't like, I'm hoping I can get better. So from Gregg at Gregg Vintage Workshop, thanks for watching. Stay safe.